This is the 15th lecture in the course 205 Signals and Systems, and today's lecture is titled Anatomy of a Class Test and a continued look at the properties of Fourier transform. This course, as you know, is based, the assessment shall be based on class tests, minor 1, minor 2 and major. This will count 20%, this will count 20%, and this will count 40%. Class tests, there will be 1, 2 and 3, and the worst of them will be thrown out, minus the worst score. So 2 of them will count, 2 out of 3 will count as 20%, and that makes a total of 40%. We had a recent test, and a review of the answers given by you show that some of the concepts are not quite clear, and therefore I shall go into the depths of this question and solve them in the manner they should have been solved. The first question in the test says the unit impulse response of a system, that is ht, is equal to delta of alpha t. That is xt equal to delta t leads to ht equal to delta alpha t, where alpha is a real positive quantity. It is claimed that the system input-output characteristics are given by yt equal to x of alpha t. Okay, it is claimed. Do you agree with the claim? If yes, justify the claim. If not, find the correct relationship. Also, what happens when alpha is negative? That is the question. I have got a spectrum of answers. The correct answer should have been like this. ht is delta of alpha t. First, let's consider alpha as positive. Then we'll see what happens when alpha is negative. So, y of t by convolution is x of t convolved with h of t, and the convolution integral is minus infinity to infinity. We can either shift h or shift x. Let's keep h the same, delta alpha tau, then x t minus tau d tau. Many of the people have shifted delta and have argued that this is the same, delta alpha tau is the same as delta tau, which is obviously wrong. And to emphasize that point, I have not shifted h of t, I have put this as delta alpha tau. Now I make a transformation, that is, I make alpha tau equal to some constant, let's say zeta. Then my integral becomes delta zeta x of t minus tau is zeta by alpha, then d tau is d zeta over alpha, and the limits of the integral, when tau goes from minus infinity to plus infinity, alpha is a positive constant, so there is no change in the limits of the integral, and that's what I get. And this is where you have to apply the definition of a delta function, that it exists only when its argument is equal to 0. Okay. So if zeta is 0, then this function simply becomes x of t, and alpha comes out of the bracket. In other words, what we have is yt becomes equal to 1 over alpha minus infinity to plus infinity, then delta zeta x of t minus zeta by alpha d zeta, alpha I have taken out. Now we argue that this function exists only when zeta equals to 0. In other words, this is 1 by alpha x of t. This is the correct answer.
Sir, but sir, we have used the condition that the system is LTI, but it's not given in the question paper, the system is LTI.
Where have you used the condition that it is LTI?
So when we convolved and we shifted the x.
That is correct. So you have to assume that the system is LTI. Yes. If it was not LTI, then it is not possible to solve for the system. Quite so. Because then it's a impulse response is a general function of t and tau. It is not t minus tau. That is, delta t minus tau does not lead to h of t minus tau. Correct? This point is appreciated. That implicit is the assumption that the system is linear and time invariant. Okay. If alpha is negative, then you see everything remains the same except that the limits of the integral, you get the same thing, delta zeta x of t minus zeta by alpha d zeta, except that the limits will now change from plus infinity to minus infinity. Alright, which you can take care by saying minus infinity to plus infinity and use a minus sign here. But since alpha itself is negative, 1 by minus alpha is a positive quantity, and therefore this simply becomes 1 by mod alpha, that is ignoring the sign, times x of t. And this result obviously is true for alpha greater than 0 or alpha less than 0. A question, can alpha be equal to 0?
No, sir.
No. Alright, that solves this question. Let's go to question number 2. It is said that if you spend a little time on reading the question thoroughly and understanding it, then half of the question has been solved. If you understand the question, half of the question has been solved. And this has been reflected in your answers to question number 2. Many of you hurriedly went into detailed equations and so on and so forth. You failed to appreciate the language. Let me read the language. It says there is a feedback system. This is question number 2. Feedback system x of t, and then there is a feedback. This goes directly to y of t. Y of t is then delayed by a quantity capital T and then multiplied by a quantity alpha. This is the system. Feedback, because this is feed forward, x of t is the given signal, part of the output is fed back to form the effective input. Alright, this input is x of t plus alpha y, this is y of t, and therefore this is y of t minus capital T, and this quantity is alpha y of t minus capital T. So this is alpha y of t minus cap t, and in other words the equation to the system is yt equal to xt plus alpha y of t minus capital T. Alright, this is the system that is given. And if you had read the question carefully, question part 1 says find the impulse response ht of this system by inspection. The word inspection is important. You do not have to solve this equation. If you look at the system, then one can easily derive what the impulse response is. Let me write the system again. I want to find the impulse response, so my x of t is delta t. Delta t comes here. This is my h of t then. And delta t is delayed by capital T multiplied by alpha and fed here. So obviously there is another condition given, that is assuming initial rest, which is important. That means ht is equal to 0 for t less than 0. For t less than 0 the input is not applied, initial rest, and therefore ht is equal to 0. Now, when delta t is applied, at t, delta t has its existence only at t equal to 0. You see there is nothing to stop delta t from going to the output. As far as this path is concerned, this path is not actuated before a time interval of capital T has passed, because there is a delay here. and therefore instantaneously ht at t equal to 0 should be simply equal to delta t at t equal to 0. Then what happens? At capital T time later, if delta t has stopped, but delta t after coming here, it has become delta t minus cap t, then it's multiplied by alpha. When it reaches the summing junction, delta t has disappeared, and therefore the only thing that you get here is alpha delta t minus capital T. This is the story at t equal to small t equal to cap t. Alright? At this instant of time, this first term has no effect. Similarly, if you keep on looking at this and simply watch the output, twice capital T instant later, another impulse shall come which shall circulate this twice, and therefore the gain shall be alpha squared. It is the same. It is this alpha delta t minus cap t which now goes like this. So it becomes alpha delta of t minus 2 cap t, then multiplied by alpha. So it is alpha squared delta t minus 2t plus etc. And this continues ad infinitum. There is nothing to stop it. And therefore this is the, to infinity, this is the impulse response of the system. Alright? And this is obtained by inspection. No solution of a differential equation is needed. And the second part of the question was, if this is h of t, find the range of gain alpha such that this feedback system becomes unstable. Now h of t is equal to delta t plus alpha delta t minus cap t plus alpha squared delta t minus 2t and so on. You are required to find out the conditions of the system on alpha such that the system becomes unstable. Now obviously I can write this as, now I will apply the BIBO condition, that is bounded input, bounded output, stability condition, and this can be written as alpha to the I delta t minus it, where I goes from 0 to infinity. Alright. So what I do is now I find out minus infinity to infinity mod h tau d tau. This mod h tau d tau, you must understand this carefully. This, what is the relationship between this and this? What is, which one is greater? The left hand side. Left hand side is either greater than or equal. Alright. Now, this is the crucial point. You have to recognize that what I have to show is that h tau is absolutely integrable if the system is to be stable. Now mod h tau, now this is a summation of terms, and I cannot use the, this is not equal to the integral with every term absolutely integrated, and therefore I use the inequality that this must be greater than or equal to h tau d tau. Now obviously if I integrate this from minus infinity to infinity, then the only thing that remains is alpha to the I equal to 0 to infinity, because integral delta t minus it from minus infinity to plus infinity is equal to 1. It must fall within the range minus infinity to plus infinity, and obviously this will tend to infinity if alpha
greater than equal to 1.
Does it have to be positive?
Mod alpha greater than
mod alpha. If mod alpha is greater than 1. Alright?
And what about equal?
What about equal?
Then also it will diverge.
Then also it will diverge. So alpha cannot be allowed to be unity either. Alright? Because it will be sum of 1, 1, 1, 1 and so on. Can alpha be equal to minus 1?
No.
Then it's indeterminate.
Then it is indeterminate. We do not know where infinity is. Well, alternate terms cancel, but I don't know where infinity is, and therefore this may not be permitted. Alright, so the condition for instability is mod alpha greater than 1. The third question, question 3, was state with reason whether the system described by the difference equation yn equal to xn plus 3un plus 1 is linear or non-linear, stable or unstable, memoryless or not, time invariant or time varying, causal or non-causal, and invertible or non-invertible. That is the question. Firstly, with respect to linearity, I told you that you need not necessarily go through alpha 1 x1 plus alpha 2 x2 and so on. You need not necessarily, because if you can find one counter example, that's good enough to show this system is non-linear. Alright? And the counter example is obvious. For a linear system, 0 input should lead to 0 output. So xn equal to 0 does not lead to yn equal to 0, and therefore the system is non-linear. Very simple. Alright. Now the question of stability. Stability. Well, mod y of n is less than or equal to, if I take the mods individually, x of n could be positive or negative, and therefore this would be less than or equal to xn plus 3 mod un plus 1. Now if x of n is bounded, x of n less than L, less than equal to L, less than infinity, if x of n is bounded, then obviously y of n is less than equal to L plus 3. At the most this can be equal to 3. If n is less than minus 1, then it's 0. But it must be less than L plus 3, which is less than infinity. And therefore the system is stable. You have to give a solid argument. You will see that in your answer scripts there are question marks. The argument is not proper or right. Then the question is yn equal to xn plus 3un plus 1. Is the system memoryless or not?
Yes, memoryless.
It is memoryless. Why? Because y of n depends on x of n only. That there is a constant term here which exists for n greater than or equal to minus 1 is immaterial. Dependence is on input and output. It does not, y of n does not depend on any of the past values, either input or output, and therefore the system does not have memory. It does not remember anything. So it is memoryless. Time invariant or time varying? It is time varying, because, well, you have to give the logic now. x1 of n leads to y1 of n, which is equal to x1 of n plus 3un plus 1. Now if you delay x1 by an arbitrary integer, let's say n naught, x2 of n equal to x1 n minus n naught, this leads to y2 of n, which is equal to x1 of n minus n naught plus 3un plus 1. This does not change, and this is not equal to y1 of n minus n naught, and therefore the system is time varying. Alright? If there is a question, please do stop me. Is it causal?
Yes.
It is causal, because y of n, by the same token, y of n depends on the present input only. It does not require the future inputs, therefore yes, it is causal, non-anticipative. Is it invertible or not?
Yes.
Invertible, that is very simple to see. It is invertible because x of n can be recovered from y of n. All that you need is from y of n you subtract 3un plus n. and therefore this is correct inverted. Okay, then question number 4. Question number 4, the question was to determine the unit step response and not impulse response. Because we did in the tutorial class impulse response example, also in the lecture here, some people, I would say a sizable fraction of the people found out h of n. There is no reason why you should find h of n. The difference equation is y of n plus 1/4 y of n minus 1 minus 3 by 8 y of n minus 2 equal to x of n minus x of n minus 1. This is the equation to be solved given that the system is at initial rest, that is y of n is 0, n less than 0, and x of n is u of n, not delta n. Obviously, you see the equation to be solved, if I put x of n equal to u of n, well, some people have found out h of n, and then they have convolved h of n with u of n. Well, this is perfectly legitimate, perfectly all right, except that they could not convolve, they could not evolve the convolution. That was the problem. There was a problem there, because h of n contained 3 terms and they didn't know what to do with the third term. Alright, the simplest thing to do is to recognize that the right hand side is indeed a delta function. X of n minus x of n minus 1 is delta n, because this is u of n minus u of n minus 1. Alright, so our equation therefore is y of n plus 1/4 y of n minus 1 minus 3/8 y of n minus 2 equal to delta n. That's it. And obviously y of n, by the usual procedure, it is the solution to the homogeneous equation yhn plus the particular integral ypn, and in this particular integral many people faltered. They took the right hand side to be 1 and there was a problem. Ypn, obviously for n greater than 0, the right hand side becomes equal to 0. The steady state solution therefore would be a constant which is equal to 0. If you put ypn equal to y, right hand side equal to 0, obviously capital Y is equal to 0. In the examples that we took in the class, capital Y was non-zero, and therefore many people were wondering as to what would happen, so they put some number, and some people even assume that y of n equal, let y of n be equal to some constant k. Now, where does this constant come from? Anyway, therefore the particular solution is 0, and our equation becomes y of n minus 2 equal to 0. This is the homogeneous equation, and the solution to this shall give you the total solution, because the particular solution is 0. And this is obviously of the form A. Now, if you want to solve this, you try a solution y of n equal to alpha to the n, and therefore you get, if you substitute this, you get alpha squared plus 1/4 alpha minus 3/8 equal to 0, and there are two values of alpha equal to half and minus 3/4. That 2, I do not know how it came, but 2 figured in many answers, that one of the possible values of alpha is equal to 2. There are also mistakes about the signs. Well, it's a quadratic equation, and I expect that you will be able to solve the quadratic equation correctly, the 2 values. And therefore, the solution is a half to the n plus b minus 3/4 to the power n. At this point, some students wondered how to evaluate a and b. Obviously, we require 2 initial conditions, whereas many of you obtained y of 0, y of n, and y of 2. And somehow or other, many of you ruled this out. You solved for a and b from 1 and 2. Well, don't you realize that to find out y of 1, you have to utilize y of 0. And therefore y of 0, y of 1 is not independent of y of 0. And therefore these 3 are not independent initial conditions. only two of them can be independent. Because calculation of y of 2 does require y of 0 and y of 1. And therefore this is a function of y of 0 and y of 1. It's not independent. Anyway, the two initial conditions would be y of n, let me write the equation again, plus 1/4 y of n minus 1 minus 3/8 y of n minus 2. Our equation was this is equal to delta n. And therefore y of 0 is equal to y of 0, y of minus 1 is 0, y of minus 2 is 0, and that is simply equal to 1. Delta n is equal to 1. And y of 1 shall be equal to minus 1/4 y of 0. Delta n has gone into the background, and therefore this is simply minus 1/4. And this is good enough to solve for a and b. Our general solution was a half to the power n plus b minus 3/4 to the power n is equal to what? This was y of n, not hn. No. This is the step response, unit step response. You can call it psi n. Alright. It depends on
n.
What depends on n?
The value.
The value depends on n. So I put the initial conditions. Y of 0 is a plus b, and this is equal to 1, and y of 1 is equal to a by 2 minus 3b by 4 equal to minus 1/4. It is at this point at least 5 students made a mistake. To solve these two simultaneous equations, if you make a mistake, this shall be punished seriously in the future. It was taken very light note of, only 50% was deducted. So A I think is 2/5. Let me see what my solution. Yes. A is 2/5 and B is 3/5. One got all kinds of numbers, 7 by 5, 4 by 5 and so on. It's a wide spectrum. This is the correct solution. And then finally, note this very carefully. Our solution is 2/5 half to the power n plus 3/5 minus 3/4 to the power n. If you had left it at this, then your solution is wrong, because you have assumed all n. Unless you specify that this is to be multiplied by u of n, well, you are to be penalized seriously in future. For the present, only 1 point out of 9. And therefore I have given 8 to those who have not written u of n. U of n must be written. The final question, question 5, was a quick one, quickly cooked one. It was x of t equal to sine pi t squared. And the question was, does it have a Fourier series representation? You have to give reasons for your answer. Well, Fourier series representation, the first and foremost condition is it must be periodic. Alright? So the question is it periodic? If you satisfy that it is periodic, then you have to go to the Dirichlet conditions. That is either of the two sets of conditions. One is energy, is it an energy signal? Or alternatively, is it an absolutely integrable finite number of finite maxima and so on and so forth. That is the Dirichlet condition. First question is it periodic? Now many of you have written correctly, no it is not, it does not have a Fourier series representation. But you went round the corner to search for a logic. Why not? Well, you see, very simple logic is this. It should have occurred to you immediately. Some people wrote that this can be written as e to the j pi t squared plus e to the minus j pi t squared divided by 2. And this is not of the form e to the j k pi t. Or e to the j omega naught t and so on and so forth. Alright. That strictly is not correct. That strictly is not the logic. Simple logic should have been, and it's a very simple problem. A simple problem should have a simple solution. Is it periodic or not? Just look at the zero crossings, or just look at the maxima. Where are the zero crossings? Xt equal to 0. Where? When t equals to 0, then plus minus 1, you see, pi t squared is 0, pi, the next 0 occurs as 2 pi, so plus minus root 2, then plus minus root 3, then plus minus 2, then plus minus root 5, plus minus root 6, plus minus root 7, plus minus root 8, and so on. Now, are these at regular intervals? Not at all. Well, they may not be regular intervals, but do they have a regularity in the pattern? For example, I could have, let's say, I could have like this interval, if this interval is the same for the next period, it would have been alright. There is neither, these are neither regularly spaced, nor is there a regularity of pattern. And therefore the system, the signal itself is not periodic, and the question of Fourier series representation doesn't arise. Some people also invoke Dirichlet conditions, but Dirichlet conditions have to be invoked only if the signal is periodic. Some of you tried to find out, and this is a correct answer, although your thinking is a bit twisted, but it is the correct answer. Some of you tried to find out AT0 such that sine of pi t squared is equal to sine of pi t plus t0 squared. He expanded this and then found out that t0 becomes a function of small t. This is a correct answer. Although, as I said, the thinking is a bit twisted. It should have occurred to you, zero crossing or even maxima. Sine is a maximum when the argument is plus minus pi by 2, maximum or minimum, alright? And therefore, if you had simply gone pi by 2, 3 pi by 2 and so on and so forth, this would also have given you the answer. Okay, now a continued look at, unless you have a question, a continued look at the character of this transformation, the Fourier transform, properties. Right, on the last occasion, that is the 14th lecture, we had left at this point, that is, if x of t is the pair of capital X of omega, then x of alpha t, where alpha is a real constant, positive or a negative, the pair is 1 over mod alpha, positive or negative, it doesn't matter, capital X of omega by alpha. Now this, along with two other examples that we have done, you see what we are doing is, is this stretching or compression? X of alpha t, it depends on the value of alpha. So it's either dilation or compression. Dilation or compression produces a reverse effect in the frequency domain. That is, it produces omega by alpha. That is, if this is a dilation, then this is a compression. Is that clear? If alpha t, if x of alpha t is an expansion, a stretch, when does it occur? When alpha is less than 1. That is, when alpha is less than 1, it's a stretching, and you see in the frequency domain it's a compression. And this is a fact of life, it's a fact of nature, that between the two domains, t and omega, both are physical domains. A frequency can be experimented in the laboratory, it can be measured, both are physical quantities, and if you stretch in one of the domains, in the other domain, it is a compression. And this is always true. You can go from here to here also. It's a one-to-one transformation. Fourier transform is a one-to-one or a unique transformation. It's a distinct transformation. The Fourier transform is looked at as a linear system, an operator. Then this operator produces distinct outputs for distinct inputs. What does it mean? In terms of linear systems, it means the system is invertible. And this is what is implied by this. That is, you can go either from t to omega or from omega to t, you shall get the same result. And this brings us to the philosophical question of duality. Alright, that is, there is a duality amongst the two domains. Let me recollect another fact of duality, that if you have in the time domain a pulse like this, minus t to plus t, and let's say this is 1, if this is your x of t, then your capital X of omega is a sin x by x form, that is it is like this, and the precise value is 2 sin omega t1. Please do remember this. You should not be required to look at your notes again and again. You must remember this like your first name. Alright, if x of t is a pulse like this, t1 and t1, capital T resolves a period, then the spectrum is twice sin omega t1 by omega. We can write this in the form of a sinc function. That's a separate story. We also remember that if in the frequency domain it is a window like this, that is minus w to plus w, if capital X of omega is like this, then its inverse transform, which we had found out last time or last before one, its inverse transform is of the same form, that is, it is of the form of sin x by x again, and precisely its value is sine of wt divided by pi t. You must remember these two, that is going from a rectangular pulse to its spectrum, or a rectangular spectrum to the time domain. Both are sin x by x form, and you must remember these constants, 2 sin omega t1 by omega and sine of wt by pi t. And you see duality being displayed here also, except for multiplying constants. The nature of the pattern is the same. If this is a pulse, a rectangular pulse, then this is an oscillating, a damped oscillating waveform. If this is a pulse in the frequency domain, then this is a damped oscillating waveform in the time domain. Now, I had promised at that time that we will take the question of duality little more analytically at a later point of time, and it is the time now to consider the question of duality. Let me state duality in precise terms. It says that if, in general, if f of t is the pair of capital F of omega, this is the theorem of duality, and we shall prove it. If f of t is the pair of capital F of omega, that is, if the Fourier transform of small f is capital F, then capital F of t, that is, if this functional form, you see in the case of the rectangular pulse, this functional form was the sin x by x. So if in the time domain this functional form comes, f of t, then this is the pair of 2 pi f of minus omega. That is, the time domain functional form goes over now to the frequency domain, except for a change of sign of the argument, f of minus omega. And to prove this, let's consider the definition of f of omega. The proof is instructive, but slightly innovative, in the sense that we use simple facts, but we use a change of variable. Let us recall that f of omega is equal to integral minus infinity to infinity small f of t e to the power j omega t dt. Is that right? Minus j omega. Alright. Now we argue that in this right hand integral, small t is a dummy variable, and therefore I can change this small t into, let's say, some other variable zeta. The value shall not change. Alright. If we do that, then we write this as minus infinity to infinity f of zeta e to the power minus j omega zeta d zeta. Alright, this is f of omega, the functional form. Now I replace omega by t. I can do that on both sides. I replace omega by t. You see, I have to bring in f of t. So what I did was, I could not put omega into t here because t already occurs in the integral. That's why I have to throw away t in favor of another dummy variable, some dummy variable zeta. Alright. Then I put omega equal to t. Therefore I get minus infinity to infinity f of zeta e to the power minus j t zeta d zeta. Alright. Let me write it again. F of t is equal to minus infinity to infinity f of zeta e to the power minus j t zeta d zeta. Now, as far as this integral is concerned, zeta is a dummy variable. The total integral is a definite integral. It's a function of time, t. So zeta is a dummy variable, and there is no reason why I cannot replace zeta by some other arbitrary dummy variable. Let's put zeta equal to minus omega. Alright. Then this d zeta would be minus d omega, and this is replaced by minus omega. And what happens to the integral? The limits of the integral, they change from plus infinity to minus infinity. But if you take care of this negative sign, then the limits can be restored. In other words, this is the same as minus infinity to infinity f of minus omega e to the power j omega t d omega. Is that correct? And what is this? Isn't this simply equal to the Fourier 2 pi times? Alright, what we do is, I write this as 2 pi times 1 over 2 pi. Then don't you see that this is 2 pi times the Fourier inverse of f of minus omega. So, I finally proved that f of t, capital F of t, is the pair of 2 pi f of minus omega. And this is the theorem of duality. If f of t is the pair of capital F of omega, then this must be true. This is the theorem of duality. In order to make an imprint of this, let me write this theorem again. F of t pair of capital F of omega implies by duality that capital F of t is the pair of 2 pi small f of minus omega. There are very interesting applications of this theorem, and there are many examples in practice which we can solve by applying this principle of duality. For example, you know that e to the minus mod t, alright, is a pair of 2 divided by omega square plus 1. We did this sometime earlier. E to the minus t ut was the pair of 1 by j omega plus 1, and e to the t u of minus t, which is on the left hand side, was simply 1 minus j omega, and therefore the sum of the two gives you 2 by omega square plus 1. Now if the question is that in the time domain the function is 2 by t square plus 1, then what is the Fourier transform of this?
2 pi e to the power minus 1.
Obviously, by applying this theorem, what we have done is omega will be replaced by t, and therefore it should be 2 pi
E to the power
f of minus omega, which simply means e to the power minus mod omega. Alright? We didn't have to integrate this 2 by t square plus 1 e to the minus j omega t. Integration is not in fact a simple integration. I mean, if you had to do it directly by defining from the definition, it would have been a tough job. We didn't have to do that. Other consequences of you recall that if x of t is the pair of capital X of omega, then dx dt is the pair of j omega x of omega. Now suppose we differentiate this. We differentiate the spectrum, that is we apply the duality principle. Then by applying the duality principle, we can easily show that this is, can you guess what this will be? X of t shall now be multiplied by jt, but with a negative sign, because of that f of minus omega, because of that negative. It can also be shown very simply from the definition. X of omega is minus infinity to infinity, x of t, I beg your pardon, I should take the inverse relationship, not this one. X of t, no, it's okay. Let's take this. Capital X of omega is minus infinity to infinity, x of t e to the plus or minus j omega t dt. Now I differentiate with respect to omega, and I can differentiate within the integral sign, because this is the variable here is small t, and therefore if I differentiate, then I get minus jt xt e to the minus j omega t dt, and therefore dx d omega is the pair of minus jt xt. It is also directly provable, but it also follows from the duality theorem. We can we have also seen that if x of t is the pair of capital X of omega, then x of t minus t0 is the pair of e to the minus j omega t0 times x of omega. Alright. Now if I do this in the time domain, that is capital X of omega minus omega 0, what is the pair of this? Obviously it should be a multiplication by an exponential. Alright. You can show that this is e to the j omega 0 t x of t, as simple as that. But this can also be proved directly. Can we do that? If you find the Fourier transform of this, instead of minus infinity to infinity x of t e to the j omega 0 t, then you multiply by e to the minus j omega t dt, and therefore these two terms can be combined into e to the minus j omega minus omega 0 t, which is simply capital X of omega minus omega 0. So this can also be proved directly. And finally, you recall that if you integrate x of t from minus infinity to t, then the Fourier transform of this is capital X of omega by j omega plus
x0
pi. Was there a pi?
Yes.
Capital X of 0, then delta omega. If I do this in the frequency domain now, minus infinity to omega, let's say, x of some arbitrary variable eta d eta, what shall we get here? We shall get precisely the same form, except that instead of t, I shall get minus t. Alright, so what I shall get is x of t by jt minus plus pi x of 0, then this is small x, then multiplied by delta t. It can also be proved directly. But you see, these relations are not relations which can be remembered easily. Alright, so one has to have a little practice in this, and I strongly suggest that you prove this directly also in the same manner, taking the even part and the odd part and so on and so forth. And this is a good point to stop for the 16th lecture.